Today we're doing Ms. Holt's favorite part of algebra or any math at all, and that's real-world applications. It's a shorter lesson today because we have a shorter period, but we're using quadratic equations to find unknown dimensions. And I'm going to do an example here, actually two examples, and then I've got a couple for you to try on the go formative. Example A says, in a landscape plan, a rectangular flower bed is designed to be 4 meters longer than it is wide. Then they tell us that we need 60 square meters, that's the total area, for the plants in the bed. And then it asks, what should the dimensions of the rectangular bed be? Dimensions, guys, that just means the size, the length, and the width. Okay, that's all that fancy word means. Okay. So first of all, we're going to draw a picture of our flower bed. Here's our flower bed. We could even draw some flowers in there. See? Yeah. You can draw your own flowers in there if you want to. But we need to figure out what the dimensions of this flower bed are. So we're told that it's 4 meters longer than it is wide. So let's just say that the width is going to be x. Let's call that x. Then our length has to be x plus 4, right? So that's our visual. We can see what's going on there. Now, as an equation, we're told, of course, that the total area, let's add that here, the total area is 60 square meters. All right, so as an equation, we know that to find area, we multiply the length times the width. So if I write that over here, it would be x times x plus 4, and I know that that area has to equal 60. So I can use distributive principle. I get x squared plus 4x equals 60. And then if I subtract that 60 from both sides, I get something that looks very familiar. It's a quadratic equation in standard form. Now, our goal here is to find out what x is. So we're finding the solution to this equation. And we've done that so many times. We know we're really looking for the x-intercepts, basically, of the quadratic equation. But we learned a lot of different ways to do it. I'm going to use factoring here. It's been a while since we did factoring. But if we draw the area model, remember when we're factoring, we put the first term here, and we put the last term here. So it's not like completing the square where we put that term off to the side. We actually put it in the box. And then we would make our big X shape to help get our thoughts organized, and we put this first term and last term multiplied together up here, so we have negative 60x squared, and then we put our middle term, which was 4x, down here. So remember, now our goal was to find something that when we multiply it together, we get negative 60, but when we add it together, we get 4. So let's think, what are some factors of 60? I think 6 times 10 might work here, right? 6x, let's try it, and 10x. Okay, now I need to get a negative 60, so I have to make one of these negative. My 4x needs to end up being positive, so I think I'm going to make the 6x negative here. All right, I think that will work. Let's put those in, 10x and negative 6x. All right, so what are my factors? I can put my x and my x here. Let's see, I have to multiply x by 10 to get 10x, so that goes there, and I have to multiply x by negative 6 to get negative 6x. So I can actually write that like this, x plus 10 times x minus 6 equals 0. So we have to find out what makes each of these factors 0. One of them has to be equal to 0 in order for our answer to be equal to 0. So x equals negative 10 would work, or x equals 6. Well, what are we looking for? We're looking for a measurement, a dimension. So does the negative value really make sense? Can it be negative 10 meters long? No. So we have to choose our positive value because that's the one that makes sense. So if we go back over here to our original problem, we know that the x equals 6. So then our length is going to be x plus 4, or 6 plus 4, which would be 10. So our flower bed is 6 meters by 10 meters. Okay, I'm going to do just one more example problem. And you'll see one very similar to this in the Go Formative exercises. It says, in a park, a picnic area is surrounded by grass in the shape of a rectangle, as shown in the diagram below. If the area of the shaded region that represents the grass is 48 square yards, what is the length and the width of the picnic area? The first question asks, how could we write an expression to represent the area of the larger rectangle? So we have the dimensions here, x plus 3 and x minus 4. And remember, area is length times width, so we could actually write that as just x plus 3 times x minus 4, right? Okay, the second question asks, how could we write an expression to represent the area of the smaller rectangle, the picnic table itself? So the dimensions of the table is x and 3. So if we multiply 3 and x together, guys, don't overcomplicate it, it's just 3x. And question number 3 asks, how could we write an expression that only represents the area of the shaded region? Well, if we know the area of the big grassy area, we already figured that out, x plus 3 times x minus 4, then we can subtract the area of the picnic table, and that would be only the area of the shaded region. So now we have an equation that represents only the shaded area, but we're told that it says if the area of the shaded region is 48 square feet. So that means we make that equal to 48, and they want us to determine what x is. So we can do a little simplification here first. Let's use an area model, first of all, to multiply those two binomials together, here and here. You have x plus 3 and x minus 4, which gives us x squared, 3x, negative 4x, and then 3 times negative 4 is negative 12. So I can rewrite that like that. X squared, see, 3x minus 4x gives me negative x. Okay, 3 times 4, negative 12, and then I have negative 3x, or minus 3x equals 48. I can combine like terms here, though, because I have a negative x and a negative 3x. So let me rewrite that. X squared minus 4x minus 12 equals 48. But note, remember when we're solving these, we always have to make it equal to 0. So let's subtract that 48 from both sides. And we end up with, I'm going to write it over here, x squared minus 4x minus 60 equals 0. Now we can solve it. So here's the final equation that we came up with. And again, to solve it, we could use factoring. So let's try it. If we make our area model, put the x squared here, put the negative 60 here. This one's looking very familiar. So if I multiply the first term and the last term together, I get negative 60x squared. And down here I put my middle term, which is negative 4x. Okay, so I'm trying to figure out what multiplies together to get negative 60, but when added together gives me negative 4. Well, we just saw this a minute ago. We saw that 10 and 6 works, 10x and 6x. This time, though, we need them to add together to give us negative 4, so I'm going to make the bigger one negative so that I end up with a negative number down there. So I'm going to make this negative 10x and 6x. There's always multiple ways to look at things. So x times negative 10 would give me negative 10x. X times 6 would give me 6x, and that works. 6 times negative 10 is negative 60. So here's my factored form, x minus 10 times x plus 6 equals 0. So either x equals 10 or x equals negative 6. Well, again, we said that we can't have a negative value for a dimension, for a length. You can't have something that's negative 6 meters long or negative 6 meters wide. So our answer here is x equals 10. But the question asks, what are the dimensions of the picnic area? So we're going to have to do a little bit more work here, not too much. We just have to put the 10 where it goes. So we know that 10 plus 3 would be 13. 10 minus 4 would be 6. So we know that the grassy area is 13 by 6. We know already that the width of the picnic table is 3, and then we know that if the length is x, that the length is 10. So we figured out the dimensions of the picnic table and the dimensions of the picnic area. And that's all for the mini lesson today, guys. The example problems that you're going to work in Go Formative, several of them, 3 of them I think are like the first one I did, and then the last problem is like this one. So feel free to go back and look at the video if you forget how to do it. And I will be on Go Formative. If you have questions, I'll be ready to answer them.